So we are doing the last lesson or the last module in Unit 8, and this is Module 8.5, and we are going to be learning about polygons on the coordinate plane. So let's look at our learning target. I can graph the vertices of a polygon, draw the shape represented by the points, and then use the graphed polygon to find its area and perimeter. And the vocabulary we are going to talk about is area, the coordinate plane, and perimeter. Now, all of this we've already done before. We've already done coordinate graphing before, the coordinate system, which is comprised of the x and y axis, as we know. And we have the four quadrants, we have the ordered pairs, we have the x and y coordinates. So we've already done this in the past, and now we are going to be making polygons on the coordinate plane and finding the perimeter. And what is perimeter? Perimeter is the distance outside a shape. All right, so it's a measure of a distance outside a shape, and area is the number of square units inside a two-dimensional shape. So let's go ahead, and I have put some points over here just so that we can see that we are going to plot a polygon. And we know that polygons like triangles, and we have quadrilaterals, the pentagon, hexagon, basically nothing but your polygons, okay? Heptagon, octagon, nonagon, decagon, etc. Are all polygons, okay? So let's look at this. I have put some ordered pairs here. Today we'll be focusing more on just quadrant 1 right now. So that means just the positive, okay? So let's go ahead and plot these points so that we can see what kind of a polygon are we creating by plotting these points. That's the first thing. So if I have 0, 0, I am going to plot that over here. This is my 0, 0, which is at the origin. Okay, so this is 0, 0. Okay, here's my ordered pair. And then this is 0, 0, which I can also write it as what? A. So I'm just going to change the ordered pair. I'm going to just write A, point A. Okay, and then point B is 3, 4. So 3 here, and then I go up here, and so this is 4. So this is my point B. And then C is 5, 4. So this is 5, and then I go here, and this is my 4. So this is C. And then I have D, which is 7, 0. So 7, 0, which is here, and that is D. So now that I have plotted the 4 points, and knowing that I'm plotting 4 points, it has got to be a quadrilateral depending on how many points are given to you, how many ordered pairs are given. If only 3 ordered pairs were given, what would it be? It would be a triangle, because it would tell me how many of the vertices are over there, right? So since it's giving me 4 points, I know that it's going to be a quadrilateral. So once I connect the dots, we are going to identify what quadrilateral is this one. So I'm going to do A to B and B to C, and then I have C to D. So now looking at that quadrilateral, what polygon was created? This is a trapezoid. This is a trapezoid. Okay? So again, what does the number of coordinate points given tell you about the polygon? And so once again, the number of points tells you how many sides the polygon has, unless 3 or more points lie on the same line. Okay? Let's go on to another one, and we are going to find perimeter and area on the coordinate plane now. So I have another set of ordered pairs that I have written over here, and I am going to graph these out to see what kind of a polygon am I creating. Okay, so A is 1, 5. So this is 1 and here is 5. So this is A. B is 7, 5. So B is 7 and we are going all the way here. So this is here. Okay, so this is B. And I can see that C is 7, 2. So 7 and 2, this is C. And D is 1, 2. So this is 1, 2 over here. Okay? Now, once I have this, I'm going to connect the dots. And what polygon have I just created? I have created a rectangle. All right? And now what I'm trying to do is I am going to calculate the distance between these points so that I can calculate the total perimeter, because perimeter is the distance around a shape. So here's the thing. We have learned how to calculate distance between ordered pairs in a previous lesson. We can either use the squares that are provided on graph paper for this, or we can calculate based on the absolute values. Okay, so if I look at this one and I know that side AD, okay, this is D, side AD is going to be 5 minus 2, because look at, I'm just going to write your ordered pairs once again. This is 1, 5, this is 7, 5, this is 7, 2, and this is 1, 2. So what is my distance over here? I can see that my x coordinates are the same and my y are different. So what is 5 minus 2? That's basically what I'm doing. I'm doing 5 minus 2 over here and I get 3. Remember we talked about this, when it's in the same quadrant, we are finding the absolute values and subtracting it. Only when a shape is in two different quadrants, then we add the absolute values, okay? But since they're in the same quadrant, this is 5 minus 2, which gives me 3. And then I look at BC, once again, over here is 5 minus 2. Absolute value of 5 minus absolute value of 2, and I get 3. So that is my distance, right? And then I look at the x coordinates. So this was subtracting the y coordinates, and now we are going to subtract the x coordinates to get this distance. All right? And so AB, if I look at AB, you can see the y is the same. So I'm going to subtract the x coordinates and I'm going to do 7 minus 1, which gives me 6. And same thing with side CD. My y coordinates are the same, so we are going to subtract just the x coordinates to get that distance. Absolute value of 7 minus absolute value of 1. So once again, 7 minus 1, and this gives me 6. Now once I have all of these lengths, all these units, I'm just going to add the lengths of the four sides. So what did I have? I had 3 plus 6 plus 3 plus 6, right? So I can write it like this: 3 plus 6 plus 3 plus 6. And that gives me that the rectangle ABCD has a perimeter of, what is this? 9 plus 9, because 3 plus 6 is 9 plus 9. And that gives me 18 units. But this is one way to solve the perimeter of a rectangle or any polygon that is provided to me. I'm going to take you here. I just wanted to show you before we do this one. Let me just go back to this because I want to show you that you can even count the number of squares. So if I have something like this given to me, and if it is graphed like this on the coordinate plane, so look, I can even count. Yeah, of course, I showed you using the absolute value, but I can also count and solve this. So this is what I mean by that. Okay, so we can do this. Each is 1 unit. This is 1 unit, this is another unit, this is another unit. 4, 5, 6. Okay, so this whole thing is how much? This is 6. If this is 6, that's a rectangle. This is 6 also. All right, and then we can count up and down. This is 1, this is 2, this is 3. So this whole thing is how much? This is 3. If that is 3, the other side BC is also 3. So now same thing, 6 plus 6 is 12, plus 3 is 6. So 12 plus 6, and I get 18 units as my perimeter. Okay, so this is one way to solve it, and then the other way was by calculating based on the absolute value when finding the distance between 2 points. All right, let's move on to this figure over here. And now we are finding the perimeter of an irregular figure. We're finding the perimeter of an irregular figure. Okay, so if you see over here, this is what I have drawn out. So once again, there are 2 ways of doing this. I can easily count how much I'm moving, and then I can add it all up. So let me go ahead and do that method first. I'm just going to count. Since it's already graphed for me, I can easily count how much I'm moving. So let's say from here to here, I can already see from all the way here, but I'm looking at the perimeter, right? What do I have here? This is 10. So this is 10 units I'm moving up. Okay? Then I look from here and this much. And how much is this? This is 7. Look, 1, 2, 3, 4, 5, 6, 7. This is 7. Okay? And then we have over here 1, 2, 3. So this much is 3 over here. And then here I have 1, 2, 3, 4. And that is 4 units. And then over here I have once again 1, 2, 3, 4. So this much is 4. And here I have 1, 2, 3, 4. So this is 4. This much is 1, 2, 3. So this whole thing is 3. And then as I can see, this much is going to 7. So this is 7. Now, once I have all of these calculated, because this definitely is an irregular figure, so for me to see the perimeter, which is the distance outside this irregular figure over here, I'm going to take all of these numbers that I just calculated and I am going to add them up. So to find the perimeter, I am going to add, it is 10 plus 7 plus 3 plus 4, 4, 4. So there are 3 4s. 1, 2, 3 4s. Plus I have a 3 over here. Plus I have a 7 over here. So you've got to add all the distances. And then when I add this all together, I am going to get 42 units as my perimeter. I'm going to get 42 units as my perimeter. All right? And then once again, the other method is what I had just shown you earlier, and that is by taking the absolute values and subtracting it, and I can do the horizontal line segments or I can do the vertical line segments. So then the other method, the first method I showed you was sitting and counting it all around. The other method that I could use is using the coordinates to find the distance. And you can find the lengths of the horizontal line segments by subtracting the x coordinates. So if I say tigers to elephants, okay, tigers to elephants, this is going to be my 11 minus the 7, 11 minus 7, and I'm going to get 4. Okay, so again, what am I doing? I'm finding the lengths of the horizontal line segments. So I'm going to start with the horizontal line segments, and I get tigers to elephants is 11 minus 7. Aquarium to rhinos is also 11 minus 7, and that gives me 4. And then I can do reptiles to entrance is going to be 7 minus 0. Reptiles to entrance is going to be 7 minus 0, which gives me 7. And then I have gorillas to monkeys. So gorillas to monkeys is 7 minus 0, which gives me 7. So first I did the horizontal distance and by subtracting the x coordinates. And then I'm going to find the lengths of the vertical line segments by subtracting the y coordinates. So if I do the vertical distance now by subtracting the y coordinates, so this is horizontal and that is vertical. For the vertical ones, I have gorillas to elephants. Okay, so my gorillas to elephants. So let's look at that distance, and that is going to be 10 minus 7. 10 minus 7, okay? 10 minus 7, that gives me 3. All right, and then I'm going to do tigers to aquarium. Tigers to aquarium, and that is again 7 minus 3. Tigers to aquarium, and that is 7 minus 3, which gives me 4, and that's my distance. Then rhinos to reptiles. Okay, so from rhinos to reptiles, as you can see over here, it is going to be 3 minus 0. Okay, this over here, 3 minus 0, which gives me 3. And then the last vertical one is from monkeys to entrance. Monkeys to entrance. Monkeys to entrance is 10 minus 0, which gives me 10. And now when I have all these values, I am just going to add 4 plus 4 plus 7 plus 7 plus 3 plus 4 plus 3 plus 10. And when I add all of these, I am going to get 42 as my perimeter. So either of these methods is fine, and the perimeter of the exhibit is 42 units by adding 4 plus 4 plus 7 plus 7 plus 3 plus 4 plus 3 plus 10. So all of these values, all right? So that is one way that this can be done. Let's look at another one really quick. So here's the next question. It's saying, find the perimeter of the outlined section of the park shown on the coordinate plane. So I'm going to use the counting method since it's already drawn out. Okay, so as I can see over here, from 0 all the way here, it is how much? It is 16. Let me use a black color. This much is 16. Okay, this much is 16. Then if I'm looking over here, it's saying 0, 9. So this much is 9. If this much is 9, how much is this much? This much is also 9, right? And then if I look at this, this is 1, 2, and this is 3, 4, right? This is 4, and this much over here, 1, 2, 3, 4, 5. This is 5. And then let's see what is over here. We have 1, 2, 3. This is 3. If that is 3, this is also 3. Right? And then let's look on the top. We have 1, 2, 3, 4, 5, 6, 7. And this is 7. Okay? And now let's look at all of them when we combine it. I have the 9 plus 9, which is 18. Then I have plus 16. Plus I have the 4 plus 3 plus 7 plus 3 plus 5. So when I add it all up, I'm going to get 56 units, which is the perimeter of this park, which is the perimeter of this park. I also like to show you one thing. Along with this, yeah, I understood how I calculated each of this, and I got 56 units by adding up all the different sides, okay? But I know if I look at this, look, this is actually going on here, this is going on here. So if I do this, look, this is the whole thing, right? And then this and this, if I do this, this is this. So literally it has actually formed what? It's a rectangle, right? So I could have also done this. If this is 16, this whole thing on the top, this whole thing on the top is how much? This is 16. Okay? And then if I have 9 and I have 3, how much is this whole thing? This is 12. So if this is 12, how much is this whole part? This is also 12. Now I have 16 plus 16, okay, which this gives me 32. And then I have 12 plus 12, which gives me 24. Now, let's look at this. What is 32 plus 24? And I actually again get the same answer, which is 56 units. So this actually makes it very easy. If you look at that shape as a rectangle, you know that in a rectangle, the opposite sides have the same value. So if you have something like this, think of it this way. This is 16. So from here, 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 all of this as a straight line would also be 16. And then if I'm looking at this 9 and this, if it's looking at it as the whole thing, if this is 12, I know this whole thing is also 12. So that makes it so much easier to calculate when we are trying to find the perimeter. Okay? All right. Let's do a problem where we are using the coordinates to find the perimeter of the rectangle. So, I have already drawn this one out for you over here, so I'm going to show it to you, and then we are going to find the perimeter of that rectangle. All right, so if I look at this one, I am just going to do this, and here it is. Okay, so I've already drawn it out, and then I'm trying to find, drawn the sides over here. So all I'm doing is I'm trying to find the length of the units, and then I'm just going to add it up. So if I look at this, now I can use either distance or I can count. Either way is fine, okay? If I was using distance, I'm looking at the horizontal distance. Remember, my y coordinates will be the same and my x will be different. It will be 7 minus 2. And what is 7 minus 2? Absolute value of 7 minus absolute value of 2, because I'm finding distance. And this much is going to be 5. If this is 5, I know this is also 5. And then I'm going to look at the vertical distance. And I know my x coordinates will be the same, but my y coordinates will be different. So if I'm looking at the length of AD, it's going to be 8 minus 5, which gives me 3. If this is 3, BC is also 3. And now all I do is add them up. 5 plus 5, 10, and plus 6, which gives me 16 units. The rectangle ABCD has a perimeter of 5 plus 5 plus 3 plus 3, which is 16 units, is the perimeter of this shape. And I could have also done this. I could have just done 1, 2, 3, 4, 5. I'm counting this, each of these. If this is 5, this is 5. And then I can count over here, 1, 2, 3. If this is 3, this is also 3. So both methods are perfectly okay, whichever works for you. All right? Now, and I'm going to go on to find the area of polygons now. So it's telling me that the polygon has these vertices over here that have been provided. And first, of course, I know that since only 3 ordered pairs are given to me, this is definitely going to be a triangle. Okay, this is going to be a triangle. So let's look, and absolutely, there is my triangle. And so what I'm trying to do now is I am going to find the area of this shape. Okay, what is the area of a triangle? Remember, the area of a triangle is half base times height. Okay, half base times height, because it is, remember, a triangle is half of a quadrilateral. Okay, so if I had drawn this, what is this? This is a quadrilateral, and a triangle is half a quadrilateral. Okay, so if I look at this, I'm going to look at the length of AB. Okay, so I can say 8 minus 5, or I can do 1, 2, 3, and this tells me that this measure here is 3. Then I look at the measure or the length of segment BC, which is here, and again this is 1, 2, 3, or I can say 5 minus 2, which gives me 3. So now I have this measure, all right? So once again, what is the area of a triangle? It is 1/2 base times height. And so I am going to substitute the values that I just got, and I have 1/2 times 3 times 3. And what is 3 times 3? That gives me 9 over 2, right? And so my area is going to be 4 1/2 square units in this shape, in this triangle. 1/2, 4 1/2 square units. All right? And basically that's what this lesson is about. Either you're finding area, you're finding perimeter, but all you're doing is you can either count the squares. All right, if you're finding area, you can find each little segment that is going to be 1 unit if you're doing the perimeter, so you can count it that way for distance or perimeter. You can count each square inside the shape, or you can just use the formula based on what you're calculating the distance to be in order to find the area of the shape. So this is basically what polygons on the coordinate plane is all about. Have a fantastic day, and that concludes Module 8.